Hello friends, this is my capstone project, third capstone project on regression supervised learning, and my project name is New York City Taxi Time Trip Time Prediction. Project time is regression, contribution is individual, and my name is Arjun Sharma. So my project summary is here. As we see, we do the data processing, we just upload the data, import libraries, finding missing data, and do categorical encoding, textual encoding, data cleaning, feature engineering. Then we do EDA, and then we do supervised learning on different machine learning algorithms. As our project in our project, we have the data set of New York City uh, taxis, uh, taxis related to taxi trips, features and variables. So we have our aim is to predict the time to, trip duration of the trip by doing the by using the different machine learning algorithms, and to predict it, to make the different matrices matrices of mean square error, root mean square error, R2 R2 square, R2 square, R2 score, adjusted R2 score, and compare these different scores of different machine learning algorithms and come out with the best uh, algorithm, machine learning algorithm. Here, this is our GitHub link, and here is our problem statement in which we have to uh, predict the trip duration of our best. We have to get the try to get the best machine learning algorithm for our data set, which will predict the best outcome of our trip duration. So let us begin. Here we import the libraries. We load our data. This is the first look of our data. Here is the tail. This, here we can see there are 14,58,644 number of rows and 11 columns in our data set. This is information about our data. All the columns, all the data types of our variables are integer or float. There are only two variables whose data types are object: pickup date time and drop off date time. Uh, these are the variables. There are no duplicate values we have. There is no missing or null values in our data set. This is the visualization of this missing value. There is no missing values in our data set. Here are the number of data set number. These are the columns. Here we describe our data set, the different variables of our data set, which we describe: the main value, the number of unique values, counts, minimum value, maximum value. These are the variable descriptions in which we have pickup longitude, pickup latitude, drop off longitude, drop off latitude, distance, months, date, pickup date time, drop off date time, store and forward flag. This means that whether the vehicle memory has before starting the trip, the flag indicates whether the trip record was held in the vehicle memory before sending it to the vendor, because vendor did not have the connection to the server. So this is passenger count, number of passenger, and this is our target variable, trip duration. These are the number of unique values in each of our variable. So we can see there are categorical and continuous variables in our data set. So here we do the data wrangling. Here we calculate the distance using the GeoPy library. We use the method function from it, and we come out with a new variable distance by using pickup latitude, pickup longitude, drop of latitude, drop of longitude. Here we make a trip duration in minute. The given trip duration is in seconds, so we convert it in minutes. So now we have as we know, as we talked about, that we have the date time and drop of date time in object form. So we explore it, and we we export the pickup month, drop of month, pickup day, drop of day from it, pickup weekday, pickup offer. So now we come up with many variables from that the object type data, pickup date time and drop of date time, and we here we do the categorical encoding. Here we just encode the store and forward flag in 1 or 0. Here we change the data type of distance and so on. Now we come to the data visualization part. Here we visualize our first data, the distribution and number of pickups and drop-offs on each part of the day. On each part of the day, how do we done the pickups on and drop-offs? We divide it into the 4 categories: evening, late night, midday, morning. So in the evening time, uh, we can see that there are the highest number of trips taken in the evening time and the midday, then morning followed, and the late night has the least number of trips in the number of trips taken and the drop-offs. Here why choose this part? The specific chart used in the code are count plots, bar plot showing distribution, the pickups and drop-offs. Here, the first chart, what these are the timings. Here we had given insights. We have found 4 p.m. to 10 p.m. is the evening time, 6 a.m. to 10 a.m. morning, and 10 a.m. to 4 p.m. is the period of the afternoon for time. So the positive business impact we can see here, what we get, understanding and drop-off can help taxi companies allocate their resources more efficiently. The more efficiently the company can engage their resources by recognizing high demand periods. Taxi companies can implement dynamic pricing models. Higher prices during peak times can increase their revenue. Yes, of course. So, then next chart, a line plot on the relationship between the pickup month and trip duration. So, next we have plotted the trip duration in seconds, the total trip duration in which of the months the higher number of trips are taken. So here we get the data from the 1st of January to June only. So we can see the as the from January to June there is a significant rise, a continuous rise in the number trip durations. So we can say the least number of trips are in January month, and as the month passes to the June, the number of trips are increasing. This is the insight, and here are the what insights we can find, what the positive uh, business impact we can create here. We can engage our resources according to the demand of the trips. Distribution number of pickups during 24 hours. So we can we can see the how the in the throughout the month how the number of trips are taken. So there are number of trips. We can see there is a significant there are from the day one of the month till the uh, date 24, 25th. The number of trips are almost equal, but at the last of the month, the number of trips get reduced. Uh, there could be the reason why the number of trips get reduced at the last of the month. So, by observing the left subplot on the right, on each day you can identify the days on which the with the highest number of pickups and drop-off. These days are likely uh, these days are likely to be the busiest for taxi services. For example, as here we can see grouping the data. Next chart, grouping the data in the uh, taxi data frame and pickup month and vendor ID. So we can see there are two vendors, vendor 1 and vendor 2. So we can clearly see here the vendor 2 has always the number of trips, has higher number of the trips. Maybe he provides much better service, and the cheap and service may be the cheap, or so the number of trips taken by the vendor 2 are more, and they both follow almost the same uh, pattern of the number of trips for the throughout the month. Next, we had the fifth chart. Here we have a count plot using the passenger count column from the data set. So now we will see the number of passengers comes taken by the taken comes in the trip. So there are one has clearly we can clearly see the first passenger one number of passenger to book the trip is one has highest number, then two, then three, and the least number of four. Then so it clearly shows the people likely uh, to do trips solo. Maybe they are office workers, do the number of trips more. Now check next chart. We group the data by categorize the trip duration and count the number of trips in each category. So here we what we had done to see the timings of the trip. So from the timing of the trip, less than 1 minute or very less. The most number of trips are duration is 10 to 30 minutes and 1 to 10 minutes. Then 30 to 60 minutes trips, as we can see, there is a sudden drop from 10 to 32, 30 to 60 minutes trip. It signifies that the people book taxi for the trip duration if they had a shorter trip almost near 1 to 30 minutes. If the trip for them the trip is within the 30 minutes, they prefer to book a trip. Or if it is more than 30 minutes, so they prefer some other. Maybe they prefer by going through the metro or their own vehicles to go for the trip, which takes more than 30 minutes. So next thing is for visually comparing the distribution and central tendencies, mean and median of different numeric features in the taxi data frame using histogram and OK. So now we will see here the different features like passenger count and the passenger count, the distance, and for the uh, this uh, pickup hours and drop off hours, the its hist plot and the uh, hist plot and the box plot, how these variables are distributed, how numerical values are distributed. So first we see the passenger count. So there is some number of outliers, but most of the number of passengers are the median is 1, and mean is also less than 2. So we can see the most of the passenger are near are uh, are distributed normally. So next thing is distance. So there in distance we can see there is significant number of the mean and median is almost same, and there is a high number of outliers. So of the box plot in distance. Next is the trip duration in minute, and uh, and we can see there is a high number of outliers. As we can see, there is a median, but mean we could not see here. So we can say this is highly skewed. Is no trip duration in minute is not being plotted. Similarly with the pickup hours and the drop hours, these seems to be mean and medians to be close enough. So we can say that these are the normally plotted. So now from this we can understand that the trip duration is skewed. So here is our heat plot. We can see there how the values are correlated with each other, how the variables of our data is correlated with each other. The peak of longitude and peak of drop of longitude are has the correlation 0.78, and there is pickup month and pickup drop of month is having the 1:1 correlation, highly correlated. Pickup weekday and drop of weekday has the high correlation. Pickup hour and drop of hour is having the correlation more than 0.9. This is pair plot. So as we talk upon we are examining the target variable as our variable. How does it be distributed? So our target variable is trip duration. So the target trip duration is highly skewed, as we can see that it is right skewed. So what we had done, we had applied the log transformation to it, and after applying the log transformation, it becomes almost normally distributed, so which will be helpful for our uh, calculation. So now what we had in examining the outliers using we handle the outliers by using the quartile method. So we now we see for the duration, number of passenger and distance, we have outliers. So we use the quartile method to handle the outlier methods in all of them. We calculate the IUQR, which is equals to the trip duration Q1 is 20.25 of the quartile. The 25% of the number of the uh, variables is 0.25 quartile Q1, and Q2 is the 0.5, means the 50% of the our counts of the variables. uh, these are comes in the Q2 and similar for the Q3. So IQR is interquartile range is trip duration Q3 and trip duration Q1. We subtract both of them. Then as we calculate IQR, and then we calculate the trip duration lower limit for the trip duration and higher limit. So this is the method. This is the method which we apply for three of them, and we calculate the IQR. So what we get here is for the lower limit of the distance and the trip duration, we get the negative values, but it can't be possible. So we applied it for the more than half, more than zero. We take it as the lower limit, and for the upper limit, what we do, we use the upper quartile uh, range. uh, Sorry, we use the upper limit for the passenger count, upper limit for the distance, upper limit for the trip duration in minutes. Okay, for the upper range. Okay, similarly, we see here the distance. So distance and the uh, trip duration distribution. So we can see the distance distribution and trip duration distribution here. So now then we had done the one hot encoding and textual data pre-processing. So we do it for the we had the weekday, Monday, Tuesday, Wednesday, and pickup months also 1, 2, 3. So what we had done, we created new variables. We in the categorical form, we make it in the categorical form by using one hot encoding, and now we get more variables, and these are the distributions of our categorical variables. Feature manipulation, this is our heat map, and whatever the uh, variables which are highly correlated, we just remove them. They, Otherwise, they will unnecessarily produce the uh, overfitting and underfitting. So next is the machine learning model implementation. We implement here for the four models. And the first model we introduce is the linear regression. Then we introduce the gradient boosting, decision tree, random forest, and XGBoost models. So here, what we make a function over here for the regression evolution matrices. Uh, uh, for the matrices calculation, here we calculate the MS mean square error, root mean square S square, R2 square, and adjusted RT square, the accuracy. And we make a plot also for them. And we also plot for the accuracy also, we plot to see the actual value and the predicted value, how accurate our model is. So what we do is we split our data before, and after splitting next and next test, the test and test is split 80 by 8 by 2, 80% of the data in train for the train and 20% of the for the test. Here is the linear regression. First model is so linear regression. Here we do calculate for the test data. This is the actual and predicted outcomes. Here is the evaluation metrics, evaluation metrics for the train and evaluation metrics for the test. So we can see the R2 square value here is very less, and mean square value is high. So we can say that it is a very poor model. They can't use it. R2 score is the low and high MSC indicates this algorithm is not appropriate model. Similarly, we had done for the gradient boosting. So in the gradient boosting, we apply the gradient boosting here, and in the gradient boosting, we get better result than our previous one. So gradient boosting, we get the better R2 score accuracy than the previous one. Then we applied third decision tree. So in decision tree, we could not apply it as it is. We have to give the some parameters. We do have to do the hyperparameter tuning. Otherwise, it will make a long tree, and it will get overfitted for our model. So what we had done, we had done the hyperparameter tuning. This is what the hyperparameter tuning is done, and after the hyperparameter tuning, we get the RSC square, uh, R2 square, MSC, and other variables also. So here we can see this. These are the mean maximum depth, the mean samples leaf, mean samples. So these are the different combinations for our hyperparameter tuning. After the hyperparameter tuning, we get the this